Okay, well, that's the title, and the talk will pretty much follow that title. Doesn't always. Sometimes they just organically grow, but this one will. As Ian mentioned, it's on my mind at the moment, and it has informed some of this talk. A short while ago, I decided that I wanted to become a specialist because no one appreciates generalists. It's terrible, because most of the generalists are now actually better specialists in any random field than the specialists. But anyway, specialists eventually become gurus, and then you just have to turn up, and you get paid. And that's pretty cool, right? So on my sort of path to gurudom, I decided to focus on data visualization because it was an interest of mine, and I gave a few talks. I gave a talk at PyData last year, which I think was part of the reason why Riley contacted me. And as a result of that, kind of a book fell out. So
it's not fallen out yet.
I would like to thank the PyData organizing committee and curse them as well in equal measure, because writing a book is really kind of hard. I got my cover. I was really chuffed about this. Apparently, O'Reilly don't let you choose your animal. They have a Kabbalistic thing. They all get together and decide. But if you make a special plea, you can get the animal of choice. I used to be the best bumblebee trainer on earth, so I wanted sort of bumblebees of a sort, or at least bees. And I made a hand-wavy thing about bees turning pollen into honey, which is a bit like turning data into a data visualization. It's transformative, and I kind of wrote that on a scrap of paper and posted it off, and I got my cover. So there you go. That was cool. Right. Editors are really good. They ask you kind of questions. Such as, why are you writing this book? That got me stumped for a while. But they talk about pain points. So what's the pain point? What am I trying to address with this? For me, it was, I've been building GUIs for years. I was in science research scientist. And in Python, I went through everything. Qt, WX Python, I had all this stuff. Like all these lovely GUIs out there. None of you will ever see them because distribution is a problem. They're just lying there. They're dead. And there's this huge pressure towards data-viz on the web. There's good reason for that. The libraries are there, and the language is now very powerful. Unfortunately, Python isn't on the web, and it's never going to be on there. This is a web browser. It's not going to be a web browser. That's the problem. And so how do I join this data-viz party? This is suggestive to me. It's begging a question. You have to accommodate JavaScript if you're going to do data visualization on the web, which is basically where you want it. If you want to distribute your data-viz to every device on the planet, pretty much, then JavaScript is what you're going to have to deal with. So making JavaScript play friendly with your language of choice, which is, of course, Python, because the data processing stack is so brilliant. It's a general-purpose library. There's nothing comparable, etc. That's the question. So what's the problem here? I think having spoken to a few people, I decided I'd actually ask some other opinions rather than just rely on my own. And I got this sense that there's this thing called web dev, which is this horrible gunk that stands between Python and JavaScript, just programming, because JavaScript is just programming, and we're programmers, right? So there's this horrible gunk, and it's called, and it is hard. I used to do it back in the day for a bit, and when I first started, it was horrible. The HTML was boilerplate hell, and even now there's this toolitis, so you talk to web developers and they've got gulps and grunts and all this crap and sass, and you get this feeling there's this huge kind of stuff there you've got to eat your way through. It's not true. You can do essentially this. You can spend 95% of your time programming in Python or JavaScript, which, as I said, is actually quite a nice language, and the only thing you need is a little bridge between them, kind of permeable membrane rather than a huge big gunk, and you pass JSON through that. And at that point, you're in a programming context. You're just programming, and eventually you kind of seamless, because the languages aren't that different. There's some syntactical differences, but they're not profound. So this is the proposition. The proposition is that you can take a small HTML5 skeleton, little CSS, JavaScript as your data format, a RESTful API, Python can roll these in a few lines, as I'll show you. And then you're just programming. You're just creating data visualizations. In this case, it could be anything else. It could be very interesting other things, but in this case, and you can call it a one-page app, which essentially means it's a folder. You can take it, you can drop it in a website, and it'll just work. So what do we mean by web visualizations? Anyway, this is a completely made-up graph. But I think there is an axis of exploration and presentation. And I think that many of us have been on various points in this kind of graph. But at the bottom, for my eyes, this is the dark, secretive data-viz that we all do when we interact with Python notebook or something. We're trying to find something. We don't intend to share it. We don't intend to distribute it. And at the old school, you've got old school static viz, which is essentially what visualization on the web has been up to now, which is just replacing newsprint with pixels. That's all it is. You know, it's not clickable. It's not interactive. But now, with libraries like D3, the power is there to make these web vizzes completely dynamic, interactive, exploratory, and we can start to take data-viz, this static kind of web viz, into the exploratory mode. So I think all the fun is in the middle. The middle is where you say, look, I've got editorial content. I'm going to give you some facets, some basic sort of impressions of this data, but I can't intuit what you want exactly. I'm going to let you explore. And I hope to make that clear in a minute what I mean by that. I thought for this talk I should code an original visualization. And I think I was inspired by, Andrew Clegg gave a very good PyData talk on data-viz. And here it is. And I'm very proud of it because I've arranged these numbers in such a way that they're very easy to read and digest. You can see the patterns in them. This was kind of my starting point, right? Difficult to make sense of that. So I just thought, hey, if I order them in columns, that's amazing, right? So I've transformed the data into something that is, if you look at it long enough, you'll probably work it out. But some people would say that that is a better way to represent those numbers, right? I mean, I don't. I think the jury's out. But, so what's all this about? It's lovely, isn't it? It's hypnotic. What am I suggesting? What's my big thing? It's about transformation. Data-viz is about transformation. It's about taking this abstract data, which has no shape or structure, and turning it into something that gets into our primary visual cortex, because that's where human beings like to play. Now, I did that. I want to make the point, I had that idea as a gimmick, as a sketch. As soon as I thought of it, I was programming it, and it was done within 45 minutes. Not because I'm any great genius, because Mike Bostock, the creator of D3, would do much more elegant code, but because when you start using D3, which is an amazing library, you start to get to the point where that gap between thinking of something and doing it becomes very narrow. And I also want to show the web dev overhead for this. This is the index.html involved. That is all of the web dev shim, if you like. That's it. This is a valid index.html. This is a valid HTML5 page. This has got all the CSS involved in that amazing visualization. It's got little tags for the control buttons and the charts. It's got the skeleton. And everything else is just programming, which is empowering, right? Because you couldn't do that with Tableau or any of that stuff. You can only do that when you get in a programming environment where you've got a rich library that's incredibly well designed using what's the grammar graphics, which is kind of the basis of it. That's just code. It's JavaScript, not Python, I'm afraid to say. But I'm not afraid to say it because JavaScript's actually much nicer than you might have heard, and it gets better and better. This is this is kind of like a shout out for D3. D3 is just this astonishingly good library. It's based on Wilkinson's grammar graphics, which ggplot2 is based on. That's the R library that all Pythonists are terribly, terribly envious of, with good cause. There's a reason why they're both very famous and they both work well. They're implementing this very profound book. The theoretical core is very strong. And as I said, Mike Bostock, the creator of D3, coded it in JavaScript when it was called Proto-Viz. That was when JavaScript was a toy language. And so I think that was an amazingly kind of insightful thing, or prescient rather. The thing about it is it's not a charting library, as you might have heard. You can use it to build charting libraries, but it starts to suggest new forms of data. I think we're on the cusp of new ways of visualizing data. Bar charts are actually optimal for many things, but there's so many more things out there. So this is the data-viz toolchain, which is the base of the book. I thought in its transformative vein, how do we take I wanted to transform a Wikipedia page, the Nobel Prize page, which is just a list of names, into a modern into a modern visualization. And I wanted to do that in order to use all the libraries that Python has to hand. We've got Scrapy for scraping, Pandas for cleaning, exploration, we've got Flask to deliver, and it's all done with JSON out of HTML, and it eventually transforms into this library. So, Scrapy is, I needed dirty data, so scraping is great because it usually produces reliably dirty data because you're scraping human-produced data of human consumption, so it's usually fairly, yeah, unclean. Plus, Scrapy is an amazingly powerful library. Once you start using it, there's the sense of power is astonishing. You press the button and it just drags down all these data. If you want data training sets, if you want sets of photos to train, just on the training level, it's fantastically useful. But it's very well written and very powerful, and when you get used to it, you get much quicker at implementing these things. To use Scrapy, you basically just use Chrome Explorer or anything you like to get the tag, the XPath, or whatever, the elements you're interested. This is Nobel Prize winning photographs and little bio that I wanted to use for my visualization. So I work out their structure within the HTML, and then I write a spider. Scrapy uses this idea of spiders. It's made them quite easy to write. That's most of the code. It's got this concept of pipeline, so afterwards you have post-processing for images and multimedia. And obviously covered in the book, but it's quite, yeah, after a while you get better at it. It becomes quite easy to write them. And it does everything you need to do. It does throttling, it does all the sensible stuff, anonymizing. If you try and do this by hand with Beautiful Soup, you'll probably end up getting your ISP banned, and your neighbor's ISP, and maybe your town's ISP. So it's sensible when you're scraping to be quite cautious there. After scraping, you get a nice array of JSON objects, but it's probably dirty. And you want to identify, remove the anomalies, duplicates, missing fields, formatting errors, etc. Which is where Pandas comes in. This is the cleaning phase. Pandas is lovely, as I'm sure many of you are aware. The more you use it, the easier it becomes to just deal with your data, to just, you know, in this case, clean it. You load your data, and you can load it in from a database, you can load it in from a file. It's got lots of different options here. I read in my JSON data, this is straight out of the Scrapy cleaning. As you can see, it's an array of objects which describe all the Nobel Prize winners, a few thousand of them. I just do a little info on that data frame. Already I can see I'm missing some gender fields. There's place of death is not all there. Describe, you just do a describing the data frame. A whole load of pretty interesting information crops out. You've got, just here in this one thing, you can see we've got duplicates. There's Daniel Carmen here, name. We have 2 of him. What's going on there? That's going to have to be addressed. We have missing fields, many of them, but you can also see things like how many countries. 59 unique countries have won the Nobel Prize, and various other just things drop out from this very, very simple little test. There were duplicates, and these duplicates, this was a potential international incident because they were in alphabetical order. So, you know, you remove them normally, and you will tend to favor countries with letters in the alphabet lower down the order. So you just randomly permute, remove missing fields. I just find which categories are null. You can see here, Alex Carroll is misnamed. He won the, it's medicine and physiology, not medicine, so find that. This is what happens when human beings enter data. This is data death. We have, so the date of death of Johannes Diedenvik van der Waals is Diedenvik Kortweg. It makes perfect sense. Pandas makes working with dates really easy, and it parses dates pretty robustly. This is a few lines here. We try and parse the dates. Anything that fails, we just throw it out. But you can see it's a really easy way to find if your data is miscategorized, if the syntax is wrong. In this case, obviously, some of these date formats, year, day, month, woof, that's a new one. And yes, date of death living. As I said, this is what human beings do when they enter data. So you end up with your clean data. hopefully as clean as you can make it. There'll be surprises in there, but we have 858 winners, and they're fairly clean. At this point, you want to explore. Whatever your motivation, you're looking for stories, narratives, whatever you're doing. If you're trying to summarize accounts inventory, if you're trying to create a weather visualization, it's stories. It's just what people are interested in. Because everything else is just gunk, it's just a noise. So how do you find stories? Here's a very dull story. The United States has won more Nobel Prizes than anyone else by a big number. But using pandas, we can easily create little groups. Here I've just created 3 groups representing the big countries in Europe, the big countries in North America, the big countries in Asia, just to see if there's a historical trend. And what you can see is there is a historical trend. There's a huge increase in American Nobel Prize winners post-war when they started investing enormous amounts of money post-Manhattan Project. And around about the 1980s, they passed the kind of fairly pedestrian European countries and kept on climbing. So that's a story. That's a historical trend. This is a huge story. Look at this. I mean, a couple of lines of pandas. The gender disparity in Nobel Prize is astonishing. There it is, a couple of lines of pandas. Age of winners. If you haven't won it by about 105, you're probably not going to get a Nobel Prize. Around about 60 odd, so you can, if you're an academic and you have a kind in mind, you can work out your odds if you're a famous Nobel Prize winner, potentially. This is nice. This is, of course, called a violin plot. It's Seaborn. Seaborn is a lovely extension to a matplotlib. And you can see here, they're a remarkably long-lived bunch, Nobel Prize winners. They regularly into their 80s, 90s, far higher than the national norm. Now, of course, they are selected at an elderly age, so there's a filter, but it's still pretty impressive. So this gives you essentially this is a box plot with a distribution plotted. It's very nice. You can do interesting things like looking at the correlation between longevity and when they won their prize. So here you can see, as you'd probably expect, this is epidemiologically, they're increasing in life expectancy. And this is a lovely little LM plot. This is one of Seaborn's built-in statistical plots, and it gives you a confidence interval as well, which in this case is pretty high. This is a nice one. This is a nice story. Nobel diaspora. The data in this Nobel Prize set had sometimes people have been. This is Wikipedia, so it's a bit of a freefall. Sometimes people have been included by both the nationality when they won the prize and their original nationality. That's part of what the duplicates were. And of course, this suggests a correlation between the original country and the country where they won the Nobel Prize. This is a diaspora. They have moved. Is there an interesting story in here? And of course, if you can see, there is. That there and that there is, when you start looking behind it, that's Jewish scientists fleeing the Nazis during World War II. Very clever, soon-to-be Nobel Prize winners. There is another one, mirrored, which is part of the Austro-Hungarian Empire, collapsing at the end of the Second World War. It then became quite anti-Semitic, and a lot of Jewish scientists and writers moved to America. So this plot here is then moving to America. A lot of Canadians moved to America as well. I'm sure a lot of Americans go the other way. Anyway, so there's a story there. There's all these little dots. This is history writ large, and it's just one heat map. So after you've done all that, you need to imagine your visualization. And you just play around. You don't want to make it too complicated, too difficult, but at the same time, you want to allow people to discover some of those stories that you've just explored. And yeah, what you should probably do is suggest little kind of configurations they might want to explore. But Nobel Prize, it's geographical. You can expect a map. You want a list where you can select the subsets that you've been interested in, and the bar charts do all the standard heavy lifting with metrics, because that's useful. And then to humanize it at the bottom, we take that bio data and we take the picture and we just stick it in there, because one reason I quite like the Nobel Prize data set is lots of stories, it's very human, and it's just about big enough to have interesting trends. Then we want to deliver the data, so we've got the data, we need to deliver it to our visualization. Flask, fantastically powerful, small, succinct. This is a Mongo-based RESTful API. That's all the code required. You see here, the little settings. That should be fairly self-explanatory. And here is the server. That's it. At this point, you are serving from a MongoDB database straight through Flask, RESTfully, JSON, to your visualization. That is not very onerous. I think that's pretty strong. This is Python, right? Try doing that in R. So that, and yeah, there's things there's lots of tailorings you can do. I mean, Eve is very well written. There's a huge number of things to do, but this is just a very basic skeleton. At which point you're going to have to program in JavaScript, and I've kind of been putting off this for a bit, but there's just a little cheat sheet. It's just generally syntax. Visualization work in JavaScript is almost all declarative, functional, so you don't even have to worry about kind of the prototype thing. It's an interesting question, but I like JavaScript. I enjoy it more and more. I find things missing in Python when I come back to it, and I didn't think I would find myself saying that. But you can do things like this in JavaScript. It has first-class functional methods on arrays: filter, map, reduce. And because of anonymous functions, you can really easily incorporate them. In Python, I generally find that quite clunky. Yeah, and that's an exciting result as well. I just need to emphasize that. So the other thing is, maybe you don't know, JavaScript smokes Python for speed. So here we've got what, spectral norm is about 60 times as fast, embody 20 to 50, depends. They're doing weird things with V8, but occasionally they basically get close to C. There's a lot of bits to be working with, so you can do things which maybe surprises you that are quite ambitious. You can do them in OpenGL too. So we got our data delivery system. It's all come through from our Wikipedia page. We've transformed it, and now we want to send it to the visualization. So here's the visualization I wrote to accompany the book, which the book will teach you how to build this essentially. And let's just see a few stories. So here's one story. That's a pretty big story, I think it's fair to say. So those dots at the top are all Nobel Prizes, and for women. It looks as if there's been an improvement recently, but let's filter by category, shall we? Physics, this is a big interest of mine. Maria Goeppert-Mayer, hands up here who had heard of her. Right, well that's terrifying because she's the only woman other than Marie Curie, who you probably have heard of, to win a physics Nobel. And she won it for theoretical work, whereas Marie Curie essentially won it for doing incredibly arduous dog's bodydom. I'm not saying it's just dog's bodydom, she did, but it wasn't theoretical. So Maria Goeppert-Mayer, why don't more people know about her? She's only the second woman to win a Nobel Prize for physics. But she cropped out a couple of clicks of the button. There's a story for you. Which I said, if I had a daughter, I would want her to know about that woman. Back to all categories. What happens if we measure by country size? You know, obviously America wins on the absolutes, but it's got 300 million people. Santa Lucia does well. Derek Walcott, West Indies, got a population about 12. So Derek Walcott, when you start dividing, so we can filter that out, but let's just go for physics, because countries like Santa Lucia can't afford a big physics budget, you know, even theoretical physics. They can't even afford to give someone a pencil to do the theoretical physics. So here we go. Anyone here from Holland? Well, hey, right, shout out Holland. Holland, if you normalize per capita, not just Holland, but Denmark, Switzerland, basically the Scandinavian countries and Switzerland are all batting way above their weight.
And I'm a physicist, but I didn't win that.
Sorry?
I'm a physicist, but it's not me.
It'll happen. You're not yet 60, right? You've got a big window of opportunity. So I can prove that. I have numbers. So there's another story. Let's do one more story. The point I'm trying to make is there are stories in here. I don't know what you're interested in. I can't. Old-fashioned editorialized infographics and stuff basically say, I know exactly what you're interested in. I'm going to show it to you. Well, I don't. I can suggest using data-viz like this. But I want you to find your own stories. You might be Estonian. I'm not. If you're Estonian, you're probably very interested in Estonian winners. So let's take all the no, it's not. Let's look at one more thing. I guess this says a lot about the world. So this is the prize for economics. Almost every prize has gone to an American. It says a lot about the post-war economic consensus. I think it says a lot about economics, actually, given what's going down. But anyway, I'm not going to get political. I think I just did. There you go. Economics is stitched up, and it goes to America, which is weird. We're Europeans. We don't even, well, Some other countries are trying to use that model, but that's strange, isn't it? All the economists come from America. It looks like someone's been stitching up people. Right, moving slowly on. This is the original. Does it work? Yeah, it does. Here we go. This was the original page. So this is the list of Nobel Prize bowler. I use Scrapey to turn this. As you see, each one of these links goes to a human being, goes to the photo and the bio, and I used Scrapey to get all that. Didn't take long. Turned it into JSON, and then the idea was to transform it into what you saw. Now, what's the web dev load? I mean, how much of that horrible, icky HTML stuff do you really need for that visualization I've just shown you? Well, this is it. This is the skeleton for that. It's got the map, it's got the bar chart. That's the skeleton. And to be honest, that's less onerous than stuff I used to have to write in Qt just to get shims between that and C. That's it, and then you take that backbone and you use JavaScript to flesh it out. And as I said, that's just programming, which is what we do. It's empowering, and D3 does the heavy lifting. It's the thing I mentioned D3 because it's the best by so far a margin. Best visualization library. I don't think it's just in JavaScript, but certainly in JavaScript. A lot of people I know do it professionally, and they talk to them, and they just say they never get to that position where you can't do something. Most libraries lock up after a while, and D3 doesn't because it's very cleverly thought out. So, summary. JSON is the big deal. If you're doing data and you plan to get on the web, then JSON is really quite nice, and it's certainly what you want to be working with. Python makes that trivial. Python and JavaScript do work really well. If you get that horrible web dev gunk down, and you can get it down to a nice minimum, you're just programming. And you can think of the web page as a canvas that you would program in Python if you were doing WX or Qt. These are exciting times. The JavaScript, as you see, is very fast. It's getting faster. It's got 100% device project. If I do a little sketch in JavaScript like the one I just showed you, I then just give someone a URL, and I've shared it with them. That's a big idea. And they can look at it on their mobile. I can sit in a coffee house with someone, and they just go to that page on their phone there and then. That's a big idea. And I do that now, and you can get blasé, but I can have a talk with a friend, and they just go to my website. This guy called Maynard did this amazing visualization. You've probably all seen it on Napoleon's disastrous Russian campaign, and he combined mortality rates with geography in what was then a completely novel way. He was trying to do multidimensional data presentation, a pioneer, getting beyond pie charts. And I think we now have the tools to get beyond bar charts and to start just doing things with our data and getting into the primary hominid cortex in ways that have not been. This is virgin territory. It's exciting. That's the other thing. You want to be here if you are interested in data-viz. And that's it, sorry. I don't know why I'm apologizing. I'm apologizing because it's ended. That's why I'm apologizing. It's so great.
So we've got 10 minutes for questions around all of this, or of course you can grab Kyran when he's sitting up on the table with us during lunch. So do we have any microphones, first of all? Also, Amy's got a mic. Was there someone at the back there, close to Amy? There we go, perfect. Thank you, Amy.
Yeah, thanks. That's actually brilliant. I've been looking for a tool like that for a very long time, so I'm glad I came. I'm glad I've discovered it. The question I've got is, when you launch a query on your visualization page on the web page, does it actually query the database, or do you have to preload the stuff into D3? Sorry.
You can do both. So
in the case that we've seen.
I've got them all working differently. When I put it on my website, I don't have a server, so it's statically frozen. So that's statically frozen. But generally the model was the Flask one that I showed you. So that's essentially, if you've got any chunk of data of any size, you're going to want to be quizzing a database. But when you're prototyping, yeah, I mean, I read somewhere last week that the average web page is like 2-3 megabytes now, with all the gunk and JavaScript. So, I mean, that JavaScript, that Nobel Prize data set is quite small, so you could just buffer it. But when you get to 10 meg and stuff, then yes. And that's trivial. That's easy to do. So most of the big data stuff is going to go straight to the RESTful server. So you're quizzing the Mongo database.
Is it worth talking about that Mongo server?
Yeah, Eve is Eve is a recent Python library that, as I just showed you, it's a few lines and it turns your Mongo database into a RESTful API. Couldn't be easier, it really couldn't. And if you're bouncing your data off Mongo, you can be exploring in Pandas, update your database, and immediately have that reflected on the web. So it's very easy. It's very easy to do. Sorry? Yeah.
Have you tried it?
Scientific Python, I skip it.
There's a package where you can actually do like, I don't know, SVM or like advanced using...
Scikit.
Yeah.
Scikit-learn.
Have you tried to use it with that plugin or that data?
Not the data set, no. I'm trying to keep it very... There's a lot in the book. So the book is already very kind of full. I'm trying to avoid... Scikit-learn's fantastic. I think that data set's quite small, but I have used scikit-learn, yeah, and I'm incredibly impressed, but not for this.
I might just note there that I use scikit-learn wrapped up with NumPy inside a Flask wrapper and serve up recommender systems and the like that way, using very similar approaches to what Kyran's covered here. It just works perfectly easily.
So you're mentioning that we're going away from the static, for the pixel-based visualization to something more interactive. And you were mentioning as well with a small data set that you can just put it into HTML and then it would just run, it would just be there. As the data sets grow, you have the problem that you need a more complicated stack of technology. Which means in the end that there's a lot of effort to keeping it alive, so to say. And
right.
So in the end, your visualization, if it's not static-based, it's going to be very short-lived. We'll know about this probably in 3 or 4 years' time. So what kind of trends do you see? How are people addressing this problem at the moment?
If the visualization is important, it will be adapted and maintained. If it's a one-off, it will be a historical kind of event. I mean, it will still work, unlike almost every other visualization I've ever done. People will just be able to go there. But yeah, everything, all data needs curation. So, and if you design it well, the curation is fairly easy. If it's an API and it's a well-designed API, if it's RESTful, there's not many ways in which it can change or be sort of adapted. So I think certainly the problem of adding to your data, augmenting your data, is quite easy to solve if you factor it in beforehand. There are the tools to hand, basically.
Yeah. Hi, Kyran. If you use something like IPython notebook, you can tell a story as you go through. You've got a narrative. Is there anything in D3 or in visualizations we can guide people through the visualization to help them out?
Yeah, there are. I mean, a lot of people have said it's virgin territory, so people are exploring this. The work with the New York Times, I mean, Mike Bostock was working at the Times with various pretty cool plugins to enable interactive storytelling. They're doing some great, I mean, just things like page scrolling. It's actually, there's a good way and a bad way to do it if you want the data to change. And Mike Bostock, creator of D3, wrote this very nice library and a very nice blog post based around the problem of scrolling. So people, the main thing is a lot of this is being driven by some of the bigger newspapers. I think the New York Times have been pioneering, and so has the LA Times, the Washington Post. They're getting into it, and they're starting to find that they need these tools to hand. So they are coming out. But yeah, the idea of telling, I mean, I think the idea of having narratives there that you suggest, but also having narratives there that you can't intuit, and that's the perfect balance. So.
Thank you.
So,
Hi, great talk, thank you. I would like to ask that there is a data visualization and there is a statistics, yeah? And for example, in data visualization, we can do some very cool visualization, but which can be garbage. For example, if we plot some mean variables on sample of 10 people or 5 people, the confidence interval would be very large, and our viewer doesn't understand it, but he will see only visualization. What is the balance between data visualization and traditional statistics in order to do some very, very fancy things, but with meaning, statistical meaning in them?
I think this is about education. The reason why a lot of visualizations are kind of just trivialized, meaningless, infographic-y, is because people aren't trained in very basic statistics. I mean, they hear statistics and their brain goes off. Probably everyone in this room knows there are some basic statistical tests you should apply to any data set. I mean, I'm a kind of scientist by training, so you kind of get drummed into you. But I think a lot of people, it's a lot of people, it's snake oil and it feels good. My feeling is that you should be true to your school, so you should try not to be walked by the dark side. But visualization can do anything, and it should do things properly. And I think little things to me like mean and median, average. Our culture has decided to use mean average GDP, which is insane because Rupert Murdoch moves into your local town and suddenly everyone's a millionaire. That's obviously crazy, but we decided to use that as opposed to median average, which is a really much better one for most people. It's much closer. So already we've got, this is propaganda, right? This is where people are not educated. I believe the only defense is education, because if people are educated, they're going to look at these infographics that don't include this basic stuff, and they're inoculated. And they'll laugh at them, and they'll stone the people who made them, and they'll send them away to foreign countries and stuff, and we'll get back to how things used to be. Stocks, they're good. So.
Thanks, Kyran. Great presentation. What are your thoughts on Bokeh? Have you checked out Bokeh?
Bokeh's lovely. There's so many things that are lovely. So when I started writing the book, I was going to do a chapter on Bokeh, and I was going to do a chapter on various other things. I like Plotly, but I wanted to do it all open source and free. And Bokeh is very impressive. There were a few, at the time the ecosystem was sort of stable. I don't know if say still stable, it's not stable yet, but there were about 5 or 6 competing, Matplotlib, D3, and there was a sense that they weren't going to survive. Bokeh seems to have survived. I like it. I like the fact that, it's similar to D3. It's looking at the fundamental core of drawing. It uses canvas, doesn't use. My problem with things like Bokeh, it's a personal thing, but once you've tasted the real drug, if you never taste the real drug, it's fine, but once you've tasted it, you can never go back. Now, I look at Bokeh, I play with it, and I'm very frustrated because I can do D3, and I can kind of think of something and just do it. And that took a time.
Yeah, but you're crossing 2 languages.
Sorry?
With Bokeh, you're in 1 language, right?
Eventually, you're going to have to debug on the browser. This is the other thing. These are all kind of lies we tell ourselves. Sorry. It's like CoffeeScript, and CoffeeScript is JavaScript, right? They're all props, and you've just got to come to terms with the fact that debugging the browser is lovely. It's a very nice experience, much nicer than debugging Python. JavaScript is getting better and better, and you're going to have to come to terms with JavaScript. Someday, someone's going to write NumPy in JavaScript or something, and then it'll be ECMAScript 7, and it will actually be a really nice language. At which point, Python's going to have some problems because JavaScript's a lot faster. I think right now the thing is to be friendly, because if you try and not be friendly, if you don't make it easy for Python to interact with JavaScript, I can see Python having difficulties. Really. The momentum with JavaScript is huge. Node, I didn't mention Node, it's kind of the elephant in the living room. It's not data ready yet, but they're building those libraries. They're awful in the main, and there's a lot of horrible APIs that change every Tuesday, but they're doing it, and they've got the power. Look, 60 to 100 times faster than Python at the moment, and Python speed doesn't change very much. So Bokeh, let's get back to the question. Bokeh's lovely. I haven't got room to talk about it in my book, but I love the idea. I still think once you've tasted the real thing, it's my prejudice.
So there might be time for one more question. Is there one more question? No more questions? We can break for coffee. In that case, we'll break for coffee. So let's first of all thank Kyran for the talk.